Hey everyone, in this video we're going to understand one of the most important concepts behind real-time applications, WebSockets versus polling. Whenever you use apps like WhatsApp, Discord, multiplayer games, live dashboards, or even stock market apps, data needs to move between the client and server continuously and instantly. But how exactly does that happen? Does the browser keep asking the server again and again? Or does the server directly push updates to the client? That's exactly what we're going to break down today, in a very simple and practical way. Before jumping into WebSockets, let's first understand the actual problem. Traditional HTTP works in a request-response model. That means the client sends a request, and the server sends back a response. Simple. But real-time apps need something different. For example, if someone sends you a message on WhatsApp, you expect it instantly, not after refreshing the page. So developers needed better techniques to simulate real-time communication. And that led to polling, long polling, and finally WebSockets. Let's start with short polling. This is basically the client repeatedly asking the server, any new updates? Any new updates now? What about now? Usually this happens every few seconds. For example, every 5 seconds the browser sends another request. The problem is, most of the time, there's actually no new data. So the server keeps receiving unnecessary requests. And each request contains full HTTP headers, cookies, authentication info, and more. That means more bandwidth usage, higher latency, and even battery drain on mobile devices. It works, but it's definitely not efficient. So developers improve this idea using something called long polling. Here, instead of responding immediately, the server keeps the request open. It basically waits until new data becomes available. Once data arrives, the server responds, the connection closes, and then the client immediately creates another request. This reduces unnecessary empty responses and gives near real-time updates. But there's still a problem. We are still using HTTP underneath. So connections are constantly being opened and closed, again and again. And maintaining all these pending requests becomes complicated on the server side. Now comes the game changer, WebSockets. WebSockets create a single persistent connection between the client and server. Instead of repeatedly creating HTTP requests, one connection stays alive continuously. And the best part is, communication becomes bidirectional. That means, the client can send messages to the server, and the server can instantly send messages back to the client. No repeated HTTP overhead. No constant reconnecting. Just a fast, lightweight, real-time communication channel. This is why chat apps, live games, collaborative editors, and trading platforms heavily use WebSockets. Now let's compare all three approaches quickly. Short polling, simple to implement but high latency and huge overhead. Long polling, better responsiveness but still dependent on HTTP cycles. WebSockets, lowest latency, minimal overhead, and true full duplex communication. But WebSockets are also more complex to scale and manage. So it's not always about choosing the newest technology. It's about choosing the right one for your use case. One huge advantage of WebSockets is bandwidth efficiency. In normal HTTP requests, headers alone can easily become more than 1 kilobyte. And with polling, those headers are sent repeatedly. But WebSockets only use tiny frames, sometimes just 2 to 6 bytes of overhead. That's insanely efficient. Imagine thousands or even millions of users connected simultaneously. Reducing even a few hundred bytes per request can save massive infrastructure costs. Now here's something really important. People often think WebSockets solve everything. Not exactly. Polling creates CPU and request overhead because of repeated connections. But WebSockets introduce a different challenge: persistent stateful connections. The server now has to keep thousands or millions of connections open continuously. That means more RAM usage, connection management, sticky sessions, message brokers like Redis or Kafka, and proper load balancing strategies. So scaling WebSockets requires serious back-end architecture planning. So when should you actually use each approach? Short polling is fine for low-frequency updates. For example, checking emails, inventory updates, or occasional background refreshes. Long polling is useful when WebSockets are blocked or unsupported, especially in older enterprise environments. And WebSockets are perfect for truly real-time systems like chat apps, live collaboration tools, gaming, live bidding, and streaming dashboards. This slide basically shows why WebSockets became so popular. With polling, servers continuously process repeated requests and handshakes. But with WebSockets, the connection stays alive, so the amount of repeated network processing becomes dramatically lower. At scale, this can save huge amounts of infrastructure resources and cost. It's also interesting to see how the web evolved over time. In the early web, everything was page refresh based. Then AJAX polling became common. After that, developers started using long polling techniques to fake real-time communication. And finally, WebSockets became standardized with RFC 6455. Now the future is moving toward technologies like Web Transport and HTTP/3, which aim to provide even lower latency and better streaming capabilities. So that's the core difference between polling, long polling, and WebSockets. If you remember just one thing from this video, remember this. Polling repeatedly asks for updates. WebSockets maintain a live conversation. That single difference changes performance, scalability, latency, and architecture decisions completely. If you enjoyed this breakdown, drop a like, subscribe, and let me know in the comments what topic you want next. See you in the next video.